bromine replace fluorine? No. Nothing can replace fluorine, right? So this would be a no reaction. Alright, so those are the 4 different types of single replacements. Alright, similar in how they exchange, but different in the way they form their products. So important to make sure that you follow the guidelines inside of your reference table. Let's look at double replacement. Now, there's not as much to do with double replacements, but double replacements, you have to use what we call the solubility rules. And if you look on your reference table, right above the guidelines, you'll see the solubility rules listed. Alright, these are the rules that tell us whether something can mix with something else. If both of your pieces in your reactants are soluble, then the reaction can take place, right? Because they would be able to mix. If one of your reactants is insoluble, can the reaction take place? No, because you cannot mix something that is insoluble. So we're going to be using our solubility rules, and we're only using the solubility rules for type A. All right? Type A is the formation of a precipitate. So if you remember back from our chemical indicators, a precipitate is when you take 2 liquids, you mix them together, and you form a liquid and a solid. All right? The outline for a double replacement is the same no matter which type it is. You have the positives switching places with the positives, or the negatives switching places with the negatives. So A and C are positive, which means A and C should always be written first in your products. B and D are negative, which means they're going to always be written second. All right, no matter how you flip-flop them, you want to always make sure your product contains a positive and a negative. Don't make a product with 2 positives or 2 negatives, all right? Because then you won't have the correct products. So let's look at some of these. Let's say we have silver bromide plus gallium phosphate. Alright, so I'm going to go ahead and label this. So this is going to be A, B, C, and D. And then I want to look at my solubility rules and make sure that this can happen. So the first one is a silver bromide. Well, right here, under soluble, if you'll look, it says all bromides are soluble except 2. So, is silver bromide soluble? No. So if it's not soluble, then we don't have to go any further. Because we have to have 2 soluble pieces in order to even that rug out there.
I'm just saying, wow. Wait.
Alright, so let's say we have plus lithium nitrate. Let's change lithium. Let's do silver. Alright, sodium chloride plus silver nitrate. Alright, so again, sodium chlorine, silver would be C, nitrate would be D. So let's look at our solubility rules. I've got sodium chloride. So I'm right here again. All chlorides are soluble except silver, lead, and mercury. Well, this chlorine is attached to sodium, so this one, we're good. All right? Then I have,
Why do you choose that?
have we not already established this?
I know, but I just never asked you.
Then we have silver nitrate. So if we look up here, again under soluble, it says all nitrates are soluble. So, doesn't matter what nitrate's attached to, all of them are soluble. So both pieces are soluble, so now I can proceed. So let's find all of our pieces first. Sodium is Na. What charge is it? Yep. Chloride Cl, what oxidation is it? Chlorine? -1. Alright, silver is Ag, what's its charge? 1. And nitrate is NO3, and what is its charge? Negative. Alright, so let's write out our compound. Sodium chloride would be what?
NaCl.
Good. Plus silver nitrate. NO3. Alright. My first compound I'm going to form is A and D. So A and D is going to be sodium. D is nitrate. So how would I write that? NaNO3 plus Cb. So C is silver, B is chloride. So how would we write it?
AgCl.
Good. Alright, and this one happens to be balanced. Now, you could have a question that wanted to know which product is the precipitate. Alright? So if you had a question that wanted to know which product was the precipitate, where do you think you could look to find out that information?
And
Yeah, we're going to look at our solubility rules, right? Because if we're mixing two things that are soluble and a solid is forming, then obviously we're going to create something that is insoluble. So we just need to figure out which of these two is insoluble. So, sodium nitrate. The rule is all nitrates are soluble. Ain't that one. Silver chloride. The rule is all chlorides are soluble except who? Except silver, lead, or mercury. So this one right here, we can denote as our precipitate by putting a little s out beside. That means that it is the solid that formed in the reaction. Now, type B, same form up here. AB plus CD gives us AD plus CB. Only this is a neutralization reaction. So this one takes place between acids and bases. When you are combining an acid and a base, you do not have to use the solubility rules. So let's say we had sulfuric acid plus boron hydroxide. We know right away that it's got to be double because both things are compounds. One is an acid, bases end in what? What tells me that that's a base? Hydroxide, right? So we know then that we're dealing with an acid and a base. So I don't have to do anything with my solubility rules. So I'm going to label the parts A, B, C, D. And I'm going to break all of this apart into my oxidation numbers. So, sulfuric acid, what do we know about it? It's sulfate and it's combined with what else? Hydrogen. Hydrogen's my positive, so it goes first. Sulfate is the negative, so it goes second. Alright, tell me about boron. What's its oxidation number? Positive 3. And hydroxide is OH. And it's negative. Alright, so let's write our compound. Sulfuric acid, how would we write it? H2SO4 plus boron hydroxide. How would we write it? B, OH in parentheses, 3. Alright, now I'm ready to form my products. First product is A and D. So here's A. A is hydrogen. D is OH. What product is that? H2O. Or HOH. I'm going to leave it as HOH because it's easier to balance that way. Alright, my second one is C and B. So C is boron. And B is sulfate. SO4. Again, always make sure your positives first, your negatives second. So how would we write this one? No. B2 parentheses SO4 3. You can't exchange the baby. You can't just drop off sulfate's baby, pick up a new one.